Hello again, everyone, and welcome back to the Turf Equipment Maintenance Facility here at the Atlanta Athletic Club. Today I'm talking about setting up a cutting unit on the Peerless 7000 reel grinder and getting everything set up for spin grinding. And I had originally started off with making this video in two parts, starting out at the surface plate and then coming over to the grinder and kind of repeating the process. But it occurred to me that really it is the same process overall, paralleling the rollers and the reel within the cutting unit. So I'm going to make a separate video at the surface plate and start talking more about reel geometry and the different effects on that. But here at the grinder, I've got the camera set up a little high so that you can see the surface of the grinder, the top surface, and get a good visualization of the setup process here. Just as a refresher, the parts of the grinder that we're working with here, the top mounting surface that the cutting unit sits on is a set of hard chrome plated steel rails, and they give us our reference point just as we're working at on a surface plate. All the surfaces are flat to within a 1/1000th of an inch relative to the grinding head. Now I say that they're flat, they're not necessarily level. The grinder has been set up to be tilted back just about a 1/2 degree so that the cutting unit doesn't want to roll off of the front. It always wants to roll back against the rear fence. The grinding head itself is rigidly mounted, runs on 2 track shafts, and it has a central infeed point. And the infeed of the grinding head that runs the grinding head up and down is calibrated to reel diameter, just like you were working on a lathe, so that if we infeed an indicated 10/1000ths of an inch on diameter, we're only raising the grinding head 5/1000ths of an inch. The rear fence that the cutting unit sits up against has 2 posts, and those posts are adjusted so that they are parallel to the grinding axis, here the grinding head, so that when we have the cutting unit pushed up against the fence, the center line of the reel runs parallel to the grinding axis. The rear fence also has a roller jack built in so that when we move the lever over, we actually lift that rear roller up off of the mounting surface, and that isolates the rear roller and so that the rear roller doesn't affect any other part of the cutting unit during the setup process. When we're setting up a cutting unit on the grinder, we work from front to back on the cutting unit, unless we're working with a fixed head mower, and I'll get into that in a later video. So when we mount a cutting unit up on the grinder, we want to position the cutting unit front to back so that the center line of the reel is running directly over the center of the grinding wheel. And that gives us a 1-to-1 correlation between our infeed on our grinding head and the center line of the reel. So we mount the cutting unit up on the grinder, and the first thing that we do is use our pie tape, and we wrap the pie tape around each end of the reel and get a measurement and see if there's any difference, any coning in the reel. For this example, I'm going to be using this piece of pipe to represent the reel so that you can visualize what I'm talking about with setting this reel up in the grinder. After we tape the reel, we want to go ahead and lift the rear roller of that cutting unit up off of the mounting surface so that we can adjust our front roller and not have the rear roller affect any of our movements. When we lift that rear roller up, we actually form a triangle here, and the front roller will be sitting on the pads, and the rear roller is free to pivot on that center roller on the roller jack. So what we'll do, I usually start at the leading end of the reel, and in the first case, why don't we assume that the reel is a true cylinder. There's no difference between the leading and trailing end. We're just going to go ahead and give a touch-up grind on a true cylinder. We'll bring the grinding head up until we just touch a reel blade and just get some noise out of the reel blade. I don't want to hit the reel blade on the stone so hard that I actually bump the stone hard enough to see it move. I want to just hear the reel blade touching that grinding stone, but I don't want to really see any movement out of the stone. That makes sure that I'm right there. I'm not deflecting anything by hitting it too hard, getting an accurate reading on it. So I get the grinding head positioned to where I've just got some sound coming out of a reel blade, and then I will set my indicator wheel to 0. My indicator wheel is, I can move the indicator wheel separately of the in-feed wheel. So I get it set on 0, then I'll back it off a little bit, come down to the trailing end of the reel, and go through the same process. Now, ideally, if my reel is parallel to my front roller, then I will get the same sound on the trailing end at the same 0 point. If I have to go past 0, then I know that this end of the reel is sitting high. In that case, I would adjust my front roller, and since I have my rear roller up on the roller jack, it's free to pivot, and I can bring that end of the roller down. Conversely, if I hit before 0, I know that this end's low and I need to adjust my front roller so that this end comes up. So once I go back and forth through this process of paralleling the reel, then I know that my front roller is parallel to my reel, and then I can go back to the back and make sure that my rear roller is parallel. But let's, for example, imagine that this reel is 20 thousandths coned out on the trailing end. My leading end is 20 thousandths bigger in diameter than my trailing end. In that case, I would zero out on the large end of the reel and go through that same setup process, and then when I come back to my trailing end, I would want to go beyond my 0 by 20 thousandths on my indicator, because remember, my indicator is calibrated to reel diameter. So by measuring the diameter and having the infeed on the diameter, if I'm a negative 20 on the trailing end, I would want to go positive 20 on my infeed to zero out and have the center line of the reel actually parallel with my front roller. And it's the same process if I come down to this end and I hit before that 20 thousandths past 0, before that 20 thousandths plus, then I would know that this end of the reel is sitting low, and I would have to adjust my front roller accordingly. So once the front roller is parallel to the reel and locked down, then I would go around to the rear of the grinder and parallel the rear roller. Here at the rear of the grinder, I work with a dial indicator coming down onto the top of the rear roller, and I go from side to side and see if I have any difference in that height. The rear roller is still sitting up on the roller jack, so I can move that rear roller and not affect the relationship of the reel to the front roller at all. It's isolated on that center pivot point. So once I get that adjusted so that it's even, then I can lower the rear roller down off of the roller jack, and I know that the front and rear roller are going to be parallel along with the center line of the reel. And notice that I made all the changes to the cutting unit, not the grinder. This is the only grinder on the market that you don't change the grinder to match the cutting unit. You change the cutting unit to be correct, and then you know once you take the cutting unit off of the grinder, when you're done grinding, you don't have any post grind setup process. Now that's all referencing a fixed reel type of cutting unit where we have a movable bed knife. On movable style reels like the John Deere QA7, you will always have that secondary setup process on the surface plate, because in that style of cutting unit, the top face of the bolt-in bed knife is actually forming that cut line, and you move the reel down to meet that line that's established by the top face of the knife. And no matter whose grinder that you're working with, whenever you have a movable reel, you're always going to have to do your final setup on a surface plate. But the vast majority of the time, we're dealing with the fixed reel type of cutting unit, whether it's Jake, Toro, or John Deere. So on the John Deeres, the cutting unit is completely tunable. You have the eccentrics on the front rollers, and you have the rear roller adjustable with the height adjusters. So on the Jacobsen cutting units, it's the most locked in because you have a welded frame and the rear roller is fixed in the frame. In that case, if you do find that the rear roller is way out, like anything more than about 10 thousandths, you're going to have to actually swap frames in order to get everything parallel. And with the Toro DPAs, you can either shim or use an eccentric on the rear roller to get everything parallel with that cutting unit as well. On small errors with the Toro DPAs, I have had some luck loosening up the side frame bolts, giving it a wrap with a soft face dead blow on the surface of the grinder, and actually using the surface of the grinder to bring everything back into square, lock down the side plate bolts again, and you should be good to go. But I really love this grinder from the standpoint of not having that secondary post-grind operation on the surface plate. I do spot check the cutting units as they're coming off of the grinder. I check the calibration of the grinder twice a year, and the grinder really doesn't drift at all. So I know coming off of the grinder, everything's going to check out. Anything that I've ever spot checked coming off of this grinder on my surface plate has been dead on, and I really haven't had to worry about it. So that's an overview of the setup process for spin grinding on the Peerless 7000. In later videos, I'll go over things like setting up for relief grind and fixed head mower setup on the grinder. But that covers the most common of the setup processes. And I hope that you got something out of today's video. If so, please subscribe, and thanks for watching.